Embedding, Focus and Context. Data Visualization, Chapter 14. This is nearly our last chapter. It can be pretty difficult to observe macro and micro features simultaneously with complex graphs. If you zoom in for detail, the graph is too big to view it in its entirety. If you zoom out to see the overall structure, you're going to miss some of the small details. Focus and context allows us to explore interactively an area of interest, which is the focus, in greater detail, while preserving the surrounding environment, which is the context. So let's get right into the big picture. We want to reduce the amount of data we'll focus on, but we still want to see the overall data set. So to do this, we can embed focused information within the context of the entire data set. There are three ways to do this. Eliding, some items are filtered while others are aggregated. Superimpose, a local region of focus can be moved against the background. Or distortion, change the geometry and context regions get compressed and the focus gets magnified. That's an example that is the fisheye geometry, which you can see in the lower right with the distortion. Superimposition is the middle, and elision, which is where you filter some and aggregate others, is on the top there. So why would you want to embed information? Focus allows along with context, helps the user to maintain orientation by providing contextual information. Subset is chosen by the user and then drawn in detail to allow for focus on that particular area. It supports a couple of different paradigms. One is non-literal navigation, and the second is synthesis of visual encoding and interaction. Focus and context helps the user with orientation by providing contextual information. Focus and control is an example of non-literal navigation, which is the term we used in the third bullet point there. The shared idea with all non-literal navigation is that a subset of the data items are interactively chosen by the user to be the focus, and those are the ones that are drawn in detail. The key idea of focus and control is the focus set changes dynamically as the user interacts with the system, and the visual representation also changes dynamically. So let's talk about the first technique, and that's to elide. Elide is a verb that means to omit a sound or a syllable while speaking. It can also mean to join together or merge, and you see this all the time in the English language. For example, you may have heard the term captain instead of captain, wanna instead of want to, or philosophy instead of philosophy. You know, we don't typically move those syllables all together, and that's called eliding. The Ramones were masters of eliding, and there were many things they either want to do or they don't want to do. Sniffing glue definitely fell into the wanna category, while being buried in a pet cemetery was a don't wanna. If you're interested in how the degree, and then in visualization, what we do is to support eliding is we have some items that are omitted from view while others are summarized using aggregation. And typically this is done using a degree of interest function to help us determine what to show in detail. For example, we could calculate the degree of interest is equal to the interest minus the distance between the 2 points. If you're interested in how this calculation works, page 325 of the textbook has some of the details. And it's interesting to note that the distance is not necessarily Euclidean. For example, you could use other paradigms such as the Manhattan distance. Second technique is to superimpose, and this is another choice for integrating focus and context. The focus layer is limited to a local region rather than being a global layer that stretches across the entire view to cover everything. In this example, Gaussian curvature is only shown in the foreground. And this is the tool glass and magic lens system. It uses a see-through lens to show color-coded Gaussian curvature in the foreground layer atop the background layer consisting of the rest of the three-dimensional scene. Within the lens, the details are shown, and the unchanged remainder provides the context. The lens layer includes the region beneath it, obviously. Distortion is another technique, and we can use geometric distortion to integrate focus and context. We make geometric distortions of the contextual reasons to make room for the details in the focus region. So there's an example in the link, and I'll try to show that when we talk together, but fisheye distortion is basically a technique that magnifies the local region around the mouse while leaving the larger graph unaffected for context. Localized circular nature of the distortion can be seen clearly by applying it to uniform grid. And you're probably familiar with the fisheye distortion from your door viewer. Another technique is hyperbolic geometry. This is kind of related to the fisheye, but here this approach exploits the mathematics of non-Euclidean geometry to elegantly accommodate structures such as trees that grow by an exponential factor. So basically the idea is an infinite non-Euclidean plane can be mapped to a finite Euclidean circle, and an infinite non-Euclidean volume can be mapped to a finite sphere in Euclidean space. And here you see the volume being mapped to the finite sphere in the Euclidean space to show us a better overview of that tree data so that we can focus on a particular area of it by rotating the sphere. Another technique is stretch and squish. This one uses multiple foci. You enlarge some of the regions and cause others to shrink. An analogy is drawing on a piece of rubber or using silly putty to pick up and stretch out comics, if you've ever played with silly putty. So basically it uses multiple rectangular foci of global extent for distortion, and the interaction metaphor when enlarging some regions causes others to shrink. The example here is the PRI sequence juxtaposer that supports comparing gene sequences using stretch and squish navigation idiom, with guaranteed visibility of marks representing items with high importance values. So, if we want to look at something, very important in the genome, we'll select that, and that one will always remain in focus, but the others we can stretch out. Another technique is nonlinear magnification fields. Again, you're using multiple foci of arbitrary magnification levels and shapes, and the scope can be constrained to affect only local regions. You can apply magnifications to a number of different places. And the picture here is of a general framework that calculates the magnification and minimization fields needed to achieve the desired transformation of the image. So distortion and these techniques are really good, but there are some costs associated with them. So one, distance and length judgments are frequently impaired. Two, users may not be aware of the distortion, especially when viewing an unknown structure. Maintaining object constancy is a challenge, because the same object can appear in different frames. And cost of mentally tracking distortions increases as the amount of distortion increases. And fisheye lenses can be quite disorienting. So that's the end of it, and there's a fisheye lens for you to be quite disoriented with. Thanks.